I'm going to show you how to set up authentication from scratch with Hono and JSON Web Tokens. I'm also going to show you how to write tests using the Bun Test Runner for all of the authentication logic so that you can be confident your authentication is set up correctly. I'm going to quickly walk you through the outline of this video so you know exactly what to expect, and by the end of this tutorial, you'll have everything that you need to set up your own REST API authentication. So first, before we jump into any code, I'm going to give you a high-level overview of how the auth strategy works. Then we'll create a new Hono app from scratch so you can see the whole process start to finish. Third, we'll set up the database. I'll be using SQLite, but this auth strategy will work with any database. Fourth, we'll create a signup route so users can create an account in our system. Fifth, we'll create a login route so users with existing accounts can sign in. Sixth, we'll create a logout route. Seventh, we'll create a protected route that can only be accessed by signed in users. Let's get started. Let's jump into our auth strategy. There are two main authentication strategies, token-based and session-based. I'm not going to do a full comparison of these two strategies in this video because that would take too long. If you do want a full comparison, let me know in the comments, but to keep things focused in this video, I'll be showing you how to implement a token-based strategy. This strategy is really good for microservices because you don't need any kind of server-side state management, which is different from session-based strategies that do require server-side state management. The token auth strategy can be broken down into 4 steps. Step 1 is for a user to sign up for an account using email and password. Step 2 is to then hash and salt the password before storing it in the database. Why do we need to hash and salt the password? Because we want to protect our users. When a user creates an account, we need to save their email and password to the database, but we also want to protect that password. And the reason why, there are often many people who work at a company who have access to look at a database, and we don't want them to see plain text passwords that they could potentially steal. Or if the database is ever hacked, we don't want the hackers to have their passwords. So in order to prevent this, we can hash and salt the password. So basically what that means is the password will be given a set of random bytes called the salt, and then put through a hashing algorithm that will turn the password into a jumbled string of random numbers and letters. The hashed password cannot be decoded, but if the same password is put through the same hashing algorithm, it will produce the same result. And that's how we know if someone has logged in with the same password or not. You can read more about this on the Wikipedia page on salting passwords if you want some more info. Lucky for us, though, Bun has a hashing function that includes salt automatically, so we don't even need to worry about it, but it is good to know how these things are working behind the scenes. Step 3 is to create a JSON Web Token for a logged in user. Now, what is a JSON Web Token? Well, it is an internet standard for a token that holds a JSON payload. Now, what does that mean? Well, for us, it means we can store a user's ID inside of this token so that we can identify users as they request data from our API. There are a couple of benefits to this approach. First is that this approach is stateless, which means as our website scales up and we have multiple servers, it doesn't matter which server a user is accessing, they can all verify the user, which makes this a really good approach for microservices and distributed systems. And second, because we're not managing user session state in our API, it simplifies the code, making it easier to work with. Anyone can create a JSON Web Token, so in order to protect our system against hackers, we can sign our JWT with a secret key, which can then be used to verify if a token was created by our system or not. And if a token was not created by our system, then we'll reject it. If you want more info on JWTs, then I'd recommend checking out this wiki or checking out some deep dives. But JWT has been a trusted tool for authentication for a while, so you can be confident that it's going to do the job. Step 4 is to store the JWT in a cookie. And the reason why we're going to do this is because we're expecting people to use our API primarily through a browser. And since browsers automatically send cookies back to the server with every request, this is a convenient way for us to get our token back and know who is requesting data. Now that we've covered our strategy at a high level, let's start coding. So in order to set up our Hono app, you're going to need Bun installed on your computer. I already have Bun installed, but if you don't, you can come to their website here, bun.sh, and right at the top of their website, they have a couple of scripts to install Bun based on your operating system. So go ahead and do that. So now that we have Bun installed, we can go ahead and create our Hono app in the command line. So open up your terminal and we can run this command, bun create, and then we can give the name of our project. So I'll call this Bun Hono Auth and click enter. And then we can choose the Bun template and install the dependencies for the project. And we use the package manager Bun. And there we go, everything's ready. So now we can change directory into our app and we can open it with VS Code. So here is the project that we just created. It comes with one index file that has a hello world route. And let's go ahead and test this out to make sure that it's working. So I like to use this VS Code extension called REST client. And the way that this works is we can create an HTTP file. So I'll just call it index.http. And then from inside of here, we can type out our route. And this is just slash hello world. So I can leave it just like that, save the file. And then if we check our package.json, there's one script, dev, which will start our dev server. So let's go ahead and run our dev server. And we can do bun run dev. And we can see our server started on port 3000. So that's looking good. And then if we come over to our HTTP file and I click send request, we can see we got Hello Hono. Great, so the default app is working as expected. So now let's move on and start putting together our database. So for our auth setup, we're only going to need one table in the database, and that will be a users table. So let's go ahead and create that table. Inside of the source directory, I'm going to add another directory called database. That way we can keep all of our database logic inside of here, and that'll make things easy. So then let's create a new file called database.ts, and this is where all of our setup will happen. So we're going to use SQLite, and lucky for us, Bun comes with SQLite built in, so we can just import that. And there we go. We have SQLite ready to go. And the other thing I'm going to import is the join function. This will help us to create a path in our root level directory that will tell our app where the database is located. So let's go ahead and set up that path function right away. And set that to the root directory. And we can call this whatever we want. I'm going to name it db.sqlite because that's straightforward as to what it is. And then we can create a variable and set it to the type of database. So that way TypeScript knows what this is. Then what we want to do is create a function to connect to our database. So let's make that. And inside of here, we can say that if there is no database existing, then we want to set one up. If there is a database existing, then we can just return the DB as is. And then inside of here, we can create a new database if one does not exist. And we can give it the DB path that we created up above, and that will create our SQLite database in the root directory of our project here. Then we can add this function. And you might be wondering, what is this function? Well, let's take a quick look at the documentation and I'll show you exactly what this does. So as you can see here, this stands for write ahead log mode, which according to the documentation dramatically improves performance for situations with many concurrent readers and a single writer. And it's broadly recommended to enable wall mode for most typical applications. So we're going to put this into our app because it will improve our performance. Now let's jump back to our code. So now I want to create a function that will actually apply the schema and create the table in our database. So let's add that. So we can use this exec command from Bun, which will run a SQL query. So we can go ahead and create our SQL query to make the users table. And we're going to create the table if it does not already exist. That way we're not creating conflicts. And this will have an ID, which will be a text and will be the primary key. And then we're going to want the user's email. And this should be a unique and not null. This will be required. Then we'll have the password hash, which should also be not null. And then we're going to say that the user will probably have some extra data, but for this tutorial, we'll just keep it fun and say, their favorite color and maybe their favorite animal. So this will create our users table, and we want to call this inside of our function up here, apply the schema, and then we will pass it the instance of our database. Great. So now the question is, how do we know if this is working? We need to test this out and see if we can actually create our table in our database. So before writing automated tests, I like to do a quick manual test. So let's go ahead and try that out. If we come over to our index.ts file, we have our hello Hono route. What if we just go ahead and import our database con and run that function when we call our hello Hono route and see if it creates the database for us. So I can open up the index HTTP file, and then we need to run our local dev server. So bun run dev. Okay, we're running on 3000. Now if I send this request, let's see. Well, we get our hello Hono, And we also can see our DB SQLite files were created. And I have another VS Code extension, which is SQLite Viewer, this one here, which allows me to click on the SQLite file and take a peek at it. So we can see we now have a users table as well, and we've got the ID, email, password, favorite color, and favorite animal. Awesome. So our manual test worked. It looked like our database was created successfully. So now the next thing that I want to do is actually insert a user and see that that logic works. So let's go ahead and write that logic. To insert a user into our database, we're going to need a SQL query. So let's create a new file where we can store all of our queries. And inside of here, I want to create that insert user query. Now, what parameters do we need in order to make this function work? Well, to create a new user, we're going to need the email and password. But one other thing that I want to add here is the database instance. And the reason why we're going to pass the database instance is because it'll make testing easier. So when we get to automated testing in a minute, we are going to pass a test database into a function so that we don't need to worry about database conflicts when we're running our tests. And then we can import this database type from Bun SQLite. There we go. And I can do save for formatting, went against me. Now, let's go ahead and see what our query should look like. So let's have a insert query, which is going to take the database and going to run the query function. And this will be a string. So we can say insert into our users table the ID, email, and password hash. Then we want to say the values, and we will pass these in. So they will be question marks. And we can return the ID after it is inserted. Then to run this query, we would do the user is what will be returned, the insert query dot get, and we will need to pass some kind of ID. We'll do that in 1 second. So the ID, the email, and then we need the password hash, which we currently are passing just the vanilla password. So we'll hash that in just a second. And then this user is going to return the ID. Currently, TypeScript doesn't know what it's returning, so let's help TypeScript out and say this is going to be an ID of UUID, and we can import that UUID type. So let's do that. Type UUID, which comes from the crypto package. There we go. And then return the user ID. Okay, so this is a good start. If we call this function, we give it the email and password that the user is providing us, and we're going to insert that user into the database. Now, let's hash the password. So that will be one of the Bun functions. And this is an async function. So bun.password.hash, and provided the password. There we go. And we're getting red squigglies because I didn't put an async on this function yet. There we go. And now down here, when we run the query, we don't want this 123 placeholder. We want to give it the password hash. And then we also need an ID. So the crypto package gives us a random UUID function. So let's use that. And here we can say the user ID will be random UUID, and then get rid of this placeholder, user ID. All right, so there we go. We have a function that should insert a user into our database. And now we can go ahead and write an automated test for this to see if it works. Let's create a queries test file so that we can write all of our tests in there. And now I'm going to import a couple functions from the Bun Test Runner. So we're going to want describe, expect it from Bun Test. All right. Now let's create a describe block. And here we can put all of our tests for insert user. So let's start with the happy path, inserting a new user into the database. And what we want to do is import our function, insert user. There it is. And as we remember here, we're going to need our database instance as well. So let's say const database equals dbcon and import that. So now we have our database. Give that to this function. And then we're also going to need our email and passwords. So let's create a dummy one. And a dummy password. And then we can give these to this function as well, email and password. Then this is going to return for us our user ID. And we can write an expectation. So we will expect that this user ID should be defined. All right, let's run our test, and we can do that from the command line with bun test. And it looks like it passed. So let's go ahead and add a console log in here because I like to see what's actually happening when running my tests. So let's make sure we're actually getting a user ID here. And go again. Let's see, we got a promise pending. So it looks like I forgot to await this function. There we go. And now let's run it again. Okay, should insert the user into the database. Now, if we check our database, are we going to see a user in here? All right, there we have it. So in our users table, we've got an ID, it's a UUID, and it matches up here with what we just logged, 303 before, test.test.com with our hashed password and null for the other optional values. So that's looking good. But if we run it again, we're running into a problem here. So we now have an error. And why is that? Well, SQLite error, unique constraint failed, user.email. So what's happening here is our test is trying to, as we run it the second time, trying to insert test.test.com again into the database, but we had marked this as a unique field. So we're not able to add that same email again. And that's a little frustrating when we're testing. I want to be able to easily rerun my tests without running into these types of conflicts. So there is a solution for this, and I hinted at it earlier, where we set up our query to accept this DB param, and what we can do instead of passing this database, which is in our folder structure, we can pass a test database, and then we can destroy that test database after each test. So each test can have its own fresh database, which means we can just keep rerunning our tests without running into any issues or conflicts. So let's go ahead and implement that logic. So I'm going to create a new folder, and I'm going to call it a test folder inside of the source directory. And that way I can keep this new logic separate from the application code. And what I'm going to do is create a test database TS file. And this is where we're going to have our logic to create a test database for each test. So let's go ahead and import our Bun SQLite database. And then create a function for our test database. And we'll help TypeScript out and let it know that we expect this to return of type database. And then a cool thing here about SQLite is we can spin up a database in memory. So it's not even going to create a file. It'll just hold the database in memory and then tear it down as soon as the connection is lost. And that's exactly what we want for testing. So this is what it'll look like. We can do a new database just like we did before, but add memory in there. Then we can add our WAL as well. And then we want to apply the same schema that we have for our prod database. So that is convenient that we have apply schema. We put that into its own function, and then we can feed it the test database, and then we can return the database. And there we have it. That's really all we need to spin up a test database. So if we go back over to our test file, instead of using this dbcon, we can import our test database. And this will work. Let's go ahead and give it a try. And run it again. And run it again. Perfect. So we can run this as many times as we want. Let's write a couple more tests here, just to make sure that our logic is bulletproof. So another scenario, actually the one we just tested, is we expect it to throw an error if the same email is already in the database. So let's go ahead and write a test for that. Should throw There we go. Now if we duplicate this line, let's see what happens. Save that file and run our tests. Okay, so we get the unique constraint failed, which is what we were expecting. And now we just want to test that we expect this to happen. So since this second one is throwing an error, we can wrap it in a try catch and move this up here. And then down here in the catch is where we're expecting things to happen. So let's expect that the error to be an instance of, and we can make sure that it's of type error. And then we can actually expect to see those words unique constraint failed. So that will be in the error.message to match, and this is a regular expression match. So let's grab this unique constraint failed, copy that, and there we go. So our regular expression should grab that. Now we're getting a red squiggly here because TypeScript is unhappy that the error is unknown. And normally I would spend more time trying to make TypeScript happy, but inside of a test, I will just tell it to ignore that. So let's run this again. And there we go. We're seeing it pass as expected. And just for argument's sake, let's go ahead and log this error and make sure it's running. Okay, there we go. We've logged out the error just as expected. Perfect. Now there is another test scenario that I want to add in here, and that's it should throw an error if the password is empty, because that is required. So let's add that. Should throw error if password is empty. Okay, let's copy paste this and delete the password then. We're sending an empty string, and we can do a try catch here as well. We know that this is going to be throwing an error, or we are expecting it to. And we can take this same thing and let's console log this error so that we can see exactly what it prints out. Okay, it is type error, password must not be empty. So let's grab this text and add and expect like the one above with an error.message to match. Password must not be empty. And let's TS ignore that. All right, looking good. Now, what I'm seeing here is we're repeating some of this code, at least the database creation in each test. So what we can do here is actually move this to up above, where we can say let database equal the create test database. We'll remove that from each of these tests. So now they're accessing the one at the top of the file. And Bun Test has a before each and an after each function. So we can spin up a new database instance before each test runs. So let's do that. Before each, we're going to say database equals create test database. And better yet, let's not assign this. Have it be of type database. All right, and then import that. There we go. So now before each test, we're going to create a fresh database, and then after each, we are going to close the connection, database.close. Therefore, a new database will be spun up each test. So let's give that a try and make sure our refactor is working. Perfect. So at this point, our database is set up and we have a query that is working. We can insert a user. So I think it's time to move on to our sign up functionality. Let's quickly sketch out what our sign up functionality is going to look like. So we can delete this hello world. We're not using that anymore. So this is going to be a post request, and we'll say it goes to API sign up. And then with Hono, we send the context, and there we have an empty function. What's the first thing that we're going to want to do here? Well, let's add some comments. Basically, we're going to want to validate the user's input that they're giving us, which is going to be the email and password. Then we're going to want to actually insert the user into the database, which we already wrote a function for that. So that part will be easy. Then we're going to want to generate a JWT token and then put that JWT token into a cookie. Then we'll either, if all of that works, we'll send a success response. If that doesn't work, then we'll send an error message so the user knows what happened. And just to make this thing happy, get rid of our red squiggly line there. Oh, it's because I don't have a return function. So this is going to be our roadmap. Let's start with our validation. So we're going to need to install a couple of packages here. So let's open up the terminal and we'll add Zod, and then Hono has a Zod middleware. So that is the Zod validator. All right, perfect. Now that we have both of those in here, we can go ahead and add a new folder. I like to keep all of my schemas in one place. We'll do that here, and we'll call this the sign up schema. And then inside of here, what we can do is import those two packages that we just installed. Z validator, middleware, and then Z from Zod. And here we can declare our schema. So when somebody is signing up, we want them to provide us with an email and a password. So inside of our Zod object, we can say email, and then this will be a string. And Zod has an email validation built right in. Got to call that function. And so that's really handy for us. And then we want the password. Okay, did not want that import. And this is also going to be a string. And then let's say we want the password to have a minimum length of 10 characters. So we can do that with Zod as well. We can put that there into the minimum length, and then we can even put a custom error message. There you can see TypeScript giving me that autocomplete. Let's say, just to be clear, password must be at least 10 characters long. There we go. Now we need to put our schema to work. So this is where we pair it up with the Zod validator middleware. And so we're going to export another function. We'll call it the signup validator. And we can use the validator here. And this data is going to be coming in as JSON. So we can select that as our option. And we can provide it the schema we just created. So our signup schema. And then this will take a result and the context. And then inside of here, we can clean up the error messages. So when Zod sends these error messages back, they're nested deeply inside of an object. So we can pull them out and make them more front and center for the user. So let's say if the result is not a success. So let's take our result.success. If it is not a success, then we want to format our error messages. So we can return the context JSON, and we can say the errors will be the result dot error dot issues, and then map through all of these issues. And for each issue, just return the message on there. So that way we will end up with just an array of error messages instead of this deeply nested object that Zod likes to send by default. And then we can say a 400 of bad request. So they sent us either bad email or password or missing email or password. So that's what this validation is going to do for us. Now we can come back over to our index, and right here in between the route and the context, we can bring in our signup validator, import that, add another comma, and there we go. So now let's go ahead and give this a try. We can test it out manually. So if I do bun run dev, get my server back up, and then our route is API signup. So if we come here, and we can add triple $sign to create a new request below. So slash localhost 3000 slash API slash signup. And this is a post request. So we do need to match that there. So the way this will look would be post. And then we can say the content type is application JSON and add our payload here. So if we say we'll put email of testatest.com and our password will be password 123. Save that and send the request. We get hello world. So that is the response that we get, back here over at the end of our route. So now the question is our authentication, or sorry, our validation working? So if I were to omit this and send nothing, there we get an error message. Perfect. That's what we want. Errors, invalid email. So we need to provide that email. If I just say test and send that, we still get invalid email, and that is because Zod's email validation right here makes sure that there's an @ symbol and some kind of .com or .something at the end. So that's really nice. That's built in for us. So let's then test that our password validation is working. So this should be 10 characters long. If I were to just say 1, 2, 3 and then send this, there we get our error, and password must be at least 10 characters long. So that's working just as expected. Now that our validation middleware is working, we can go ahead and pull off those validated values, and I'll show you how to do that right here. So we can pull off the email and password from the context. So context.request.valid, and this is coming from the JSON body. So now we have the email and password validated. Awesome. So what we want to do then is insert the user into our database. So let's go ahead and wrap this in a try catch just in case some kind of error were to occur. And we'll say await, and we are going to get our insert user function. And this is going to take the database, as you can see here from TypeScript, as we were doing earlier. So let's add our database. So we have that imported already, our connection, dbcon. Now we've got the database, and we can pass in the email and password provided by the user. And let's see, this is upset because I didn't mark this one as async. Easy fix. And then this function is going to return us the promise with the user ID. So we can go ahead and say const user ID, and then we'll be able to use this ID in a second. Let's grab these. Now we want these to come up here, and this one will go down there. So just cleaning up our roadmap a little bit. Great, so things are coming together. Now that we have the user inserted into our database, we want to generate a JSON Web Token. So to do this, let's go ahead and create a helper file. So I'll come over here and I'll say helpers, TypeScript, and inside of here, we're going to create a function to generate the token for us so we can reuse that function. So let's say we'll call it generate token. And this will take the user ID, which we just got from our database function. And what we need to do here is we need a secret key that we can sign our payloads with. So we're going to want to pull that secret from our environment variables. So let's go ahead and see what that'll look like. To pull a secret from our environment variables, we can say process.environment, and then let's call it our JWT secret. And then we actually need a .env file to pull this from. So if we come up to the root of our project and we add a .env, we can then add our JWT secret, and this should be a long auto-generated random key. And the way to do that, we can do it in our terminal. So let's go ahead and so then from here we can open up the node REPL or the Bun REPL, and we can bring in the crypto package. So we need to require crypto, getting a little autocomplete, and random bytes, 64. That's going to be the number of random bytes. and then convert that to a string. And let's see what we get. So there we go, a gigantic string of random numbers and letters. This will be our secret key, and this is great because it's basically impossible to guess what that's going to be. So let's paste that in here. All right, save that. Now, this JWT secret will be that big long key that we had just put in. And now that we have that secret, we also want to get today's date in seconds. And that way we can put that into the payload and put it as an issued at time. So let's get now, and that will be date.now. But this is going to give us the date in milliseconds, and the convention for JSON Web Tokens is seconds. So we just need to divide that by 1,000. And then that could give us a decimal. So let's go ahead and math.floor so that it is an integer. Then we can construct our JSON Web Token payload. This will be what ends up going to the user inside of a cookie. So the convention with this is there's usually a subject called sub, and then we want to give that the user ID. And that way we know who is hitting our API. Then we also want an issued at time, which we'll say is now. And then we can set an expiration date. So we're going to leave this token valid for 1 hour. And then after that, the user would have to log back in. So to do that, we can say +1 times 60 seconds times 60 minutes. So that will be 1 hour. And then we need to actually sign this payload with our secret so that we know when we receive any JSON Web Token, we can verify it with our secret. And if it doesn't match up with our secret, then we'll reject that. And it came from someone else, some hacker potentially. So to do that, Hono includes a function for us, which is really handy. So let's see. Not able to auto import that one. Sign from Hono JWT. There we go. And then we will sign the payload with our secret. Then we can return the token. So if we hover over here, TypeScript is unhappy because this could potentially be undefined because it came from our environment, but we know that it's not undefined, so we're just going to tell TypeScript to ignore that with that exclamation point. All right, we now have a function to generate a JSON Web Token. So if we jump back over here, we can now say const token equals await and call generate token from our helpers, and we can pass it the user ID that we just created there from inserting the user into the database. And then we'll move on to putting this token inside of a cookie. So to set the cookie, Hono has some built-in cookie helpers that we can import. So let's go ahead and grab that. There's a set cookie from Hono cookie. There we go. And if we come down here and we're going to set the cookie and we want to put that that token inside of there, we can see here from the TypeScript pop-up, set cookie first takes the context. So that's this context that we have up here. And then after that, we can give it a name. Now this is anything we want to name it, and so just to be simple, I'll call it the auth token, and then this will show up in the browser. You'll be able to see that. So then the third will be the value, which for us is going to be the token. So that token will be set with that name token. And then finally, our last option are the cookie options. Now, there are a handful of cookie options, so I'm actually going to jump over to our helpers file and put the cookie options in here so that we keep our code clean. Now, let's go ahead and create our cookie options, and this will just be an object. Now, this is really important. There are a couple things on here that will help keep our application secure. So first is HTTP only, and we want to set this to true. So this prevents JavaScript from manipulating the cookie in any way, if we don't do this, then the cookie could be vulnerable to some kind of scripting attacks. Then we want to set this to secure true, but the problem here is secure true means only over HTTPS, but for testing that makes life difficult because we're not testing over HTTPS locally. So what we can do is we can set an environment variable. So when environment node env is production, then this will be true. So that makes our life just a little bit easier. And then we can set same site as either lax or strict. And this is basically going to say that we're only going to send the cookie back if it is coming from our website. We don't want cookies from other websites coming back to us or letting someone else potentially get access to our cookie. Then we can set the path of the route, and that makes the cookie available to all routes in our system. And then finally, we can set a max age. So this will set 3,600 milliseconds, which is 1 hour, which matches our token. So they'll expire at the same time. And then to make TypeScript happy, we want this to be set to cookie options. So let's see if we can get this to import cookie options from Hono utilities cookie. Yes, there we go. Awesome. So now we've got all of our security settings for our cookie. Let's go ahead and bring that back over here. Cookie options, import that and save. All right, so this is really coming together. Now we can just send back our success message. So let's do that. And this will be our context, JSON message. And the message will be something like user registered successfully. And then we can send them back their user ID and email. User ID and email. There we go. Now, if there is some kind of error, we want to send back an error message. So we don't need this anymore. And there are a couple of different situations. So I will just type this out really quick. If the error is a unique constraint failed, like we've seen before. That means the email already exists in our system. The person already has an account. So we can match on that and say if error, instance of error, and the error dot message includes unique constraint failed, then we can send back a specific message, context.json, and say the errors are email already exists, and label this as a 409. That is the status for a conflict. And if we don't have that specific error message, then it's going to be any other type of error. And for our purposes, we might want to log that error on our server so we can dig into it and just say there was some kind of sign up error and print that error. And then we can return just a 500 back to the user. Internal server error, 500. All right, so this is looking pretty good now. We have our happy path where we create the user, we validate everything, we generate the token, assign it to a cookie. Now let's go ahead and test out if this thing is working. So we can go jump back over to our index HTTP, and if we send a happy path success, so password of 123, we would expect to see that cookie come back. Oh, that's funny. So we got the 409 conflict. Email already exists because I've already created a test user in the database. So let's just say test123. And well, hey, we know that our conflict logic is working. So let's send that. And we got a 500 internal server error. Let's see what happened. The error was because I didn't restart my dev server after adding the environment variables. So if you haven't done so, kill your server and then fire it back up in order to load those environment variables back in. So now that I have those, we can go ahead and test this out again. So if I send that request off, now we are getting a success message. We got our 200 OK, and here you can see our auth token is in the set cookie, and this is what the JSON token or JWT token looks like. And then we can see our other config in here, the max age we set, the path, and the HTTP only. So everything's looking good. Our user registered successfully. And then if I jump over to the database, we can see all of the users that I have registered, including the one I just sent off, no@test.com, and the hashed password. So this is looking good. To wrap up our sign-up logic, let's write some automated tests. So this is going to be inside of our index TS file. So let's create a test file for that. We can call it index test TS. And there's a couple things that we're going to want to import here. So we are going to be importing the whole app from our root. So this is going to be our whole Hono app will be spun up and tested as we're hitting these different endpoints, which is pretty cool. And then we're going to use the Bun Test Runner. So we want to import a couple of different functions from there. So like before, we imported the describe, and we can say from Bun Test, and also expect it, and before each after each. We'll need those for mocking and resetting our database. And we'll also need mock because we will need to mock the function that connects to the database and replace it with the test database. Okay, so now that we have those things, let's go ahead and craft up just our first describe. This will contain all of our signup logic. So the signup endpoint, and get this. And let's start with the happy path. So it should sign up a user. And async. Now, to sign up a user, we need to create a request that we will send to our running app. And we can do that with a new request and give it our localhost 3000 where we're running at API signup. And this is a post request, so we're going to need to provide that data. So we will also say method and tell it that it's a post request. Post. And specify the headers, our content type of application JSON. And that's normally capital content type application JSON. And then we can add the body, which will have our email and password. And the email here could be test at, I want to make that a string, test@test.com with a password. Okay. And set this to a variable, constant rec for request. All right, so now that we have the request, we want to send it to our API. So we can say we're going to get a response back. And this will go to app.fetch with the request. And then this needs to be parsed back to JSON after we receive it. So we will await the response.json. And then we can write some expectations. So we expect the response.status to be 200. This is our happy path. And we're going to get back a message that says user registered successfully. So our JSON to equal the message of user, and this is right here, user registered successfully. Let's go ahead and copy that, save myself the typing, and we'll also get back the user with an ID, and that's going to be some kind of random UUID, so we'll just say a random or expect string of any string, and the email should be test@test.com. So there is one missing component here, and that is when we run this test, it is going to connect to our actual prod database, which is right down here, And we don't want that. We want it to connect to our test database. So let's go ahead and import our test database and mock that out. Create test database. There we go. And assign that as a top level. And we can get the type here. So that comes from Bun SQLite. There we go. Now we want to mock this whole dbcon module. So mock.module is how this works. And then we specify the path. So this is going to be in our source, and then database, and then database.ts. So that's what we're telling it to mock out. And then this takes a function. So we will return the dbcon, name of the function, and we're going to tell it to return this database instead. And variable is being used before signed, but we are going to assign it here in our before each. Before each, our database will equal our create test database. There we go. So now TypeScript is happy. And then after each, we're going to do the same thing we did with our last tests and tear down the database each time. So we'll close the connection. db.close. There we go. That should do it for us. All right, now let's give it a try. Okay, I'm gonna close that server, bun test, and there we go. It passed. Should sign up a user. Cool. Now I like to actually see what's happening here. So let's go ahead and console log our response and see what that looks like. Okay, there we go. So we got our response. Okay, true. Good. Status of 200. And as we can see here in the headers, we do have our set cookie, which has our auth token, which is great. That's what we're expecting, our JSON Web Token with these different parameters that we set on there. So we can also add some expectations on this cookie because we want to make sure that this is being sent back to us. So if we come back over here, let's pull the cookie off of the header, and we can do that with cookies equals our response dot headers. So it's right on there, and get, and then we can just say get the set cookie, which matches up with this, the set cookie. And then we will expect the cookies to match. So we'll do a regular expression match and just make sure that we have the auth token equals on that cookie. Now if we save that, do bun test, it passes again. Awesome. And we saw it working with the console log, so I'm confident this is now working as expected. And one thing I want to do is move this request out into a helper because we're going to reuse this in our next two tests that we're going to write. So we can come over to our test file and quickly add a test helpers. And we can create a sign up, a reusable function for our sign up. So let's call that our sign up request. and I want to be able to pass in an email or password to it. So we'll put that, but then also default to test.test.com if we don't provide anything. So we'll also default this one to password 123. And then let's go ahead and one over too many, copy this out, paste it here, and we will just return that and save for formatting. And instead of this being hard-coded, this will be the email that is passed into the function. We'll get set, and same with the password here, so that we can reuse this easily. Nice. And then in here, we can just say sign up request, call the function, and we don't need to provide anything here. Save, and then if we run it again, make sure it's working. Yep, everything is good. Our refactor worked. Now, let's write a test for a sad path. So, for example, our 409, if the email already exists, we're going to expect an error. So let's see. Should return 409 if email already exists. And we can use our same sign up logic there. So let's grab these two. And this first one, so we're going to hit this endpoint twice actually. Once to create a user and then a second time to try and create the same user again. So here we're going to expect that this should be a success. So response.status should be that 200 again. And then if we do the same thing, copy that down, just call this request 2, and then that's going to send the same email password again. And we can actually copy this as well, call it response 2. And then we can parse our JSON on this one. And response to .json. There we go. Now we're going to expect this one to give us a 409. So response to .status should be 409 for a conflict. And then we also pass a message with this one. So we can expect that JSON to equal our error messages array with email already exists. All right, let's give this a try. Oh, I just saw that this was unused, and that is because I had copy pasted it from above, so that should be request 2. Oh. Let's see, are we passing? Yes, so should return 409, and I'm confident that's working as expected. The last thing that I want to test with this signup logic is that we should be getting errors if email or password are missing because they're both required fields. So let's write that test really quick. Should All right, so we can say our request is our signup rec, but here we can pass empty strings, and our response now this should give us a 400 back, so let's expect that status to be 400. And we should also get an error message for each of these being blank. So let's see what that would look like. And to make things easy, I will just log this out so I can see it and then copy paste it from the terminal. It's a nice, easy way to find out exactly what's being sent back. Okay, so there it is, errors, invalid, password. We can grab that. That's exactly what I was expecting. And password must be 10 characters. And then we can clear that and put that in the equals and save for formatting. And there we go. Everything is passing. And that wraps it up for our sign up logic. All right, on to our login functionality. Let's do a quick walkthrough of what all we need to do here, the same way we did with sign up. So if we scroll down here, we can chain onto here another post request. And this is going to be /API login. And then we can pass our context. Now, inside of here, there are a couple things we're going to do. One, we're going to want to validate the user's input again. So if you're logging in, you're going to be giving an email and a password, which is the same for the signup function above. So we'll add validate user input. Then after that, we're going to need to search our database for the user by the email address that they provided. So we'll have to write a query, query user by email. Then we want to verify the password they provided to us matches the password we have saved in the database. So we can verify password matches. And then after that, if it does match, or let's say if it doesn't match, then we return a 401 for unauthorized. If match, then we want to generate our JWT and put JWT in a cookie, very similar to the sign up, and then send success if all of that goes well, or send error. So this is going to be pretty similar to our sign up, with pretty much the big difference being querying by email. So, all right, autosave, removed all of my spaces, that's fine. One thing I'll say for the validation will be very easy is that we're going to be doing the exact same validation. We just need to check the email and password are the same. So we can actually take this same middleware validator and use it right down here. And that will give us everything that we need. And then we can pull off the validated email password the same way that we did before. Off of the context request dot valid and off of the JSON body that's provided. There we go. Now let's create a new query to get a user by email. So if we jump back over to our queries, we can hide that one and say export const get user by email. And then similar to this one up here, we're going to pass in the database to make testing easier, and then pass in an email. So DB is of type database and email is of type string. And now we can write our query. So database query and this will be select the user. We want the ID and the password hash from the user table, from users where the email equals our provided email. And then we can set that to a variable when we run the query here. So we will do user query dot get by the email that is given to this function here. And then we can return the user. Now, as I'm hovering over this, you can see TypeScript doesn't know what the user is. So let's help out TypeScript a bit by giving a return type. So we know that we are requesting the ID and the password hash. So that's what's going to get returned from the database. So we can say it's going to be the ID of string and a password hash of type string. Now, if there is no user by the email address we're searching for, then it will return null. So this could also be null. Okay, perfect. So this should work for us, and we can write a couple quick tests for this to make sure that it's actually working and have some confidence in our code. So let's go ahead and make a new describe block for get user by email. And then let's do our happy path test first. So we expect it to return a user by a given email. And I think we can take a look at one of these here. Oh, I left a console log in there. We can get rid of that. Don't need that anymore. The old copy paste. Okay, but we're not going to do insert user. We are going to do get user by email. There we go, which does not take the password, so we can get rid of that. And password not necessary. And await not necessary. And yeah, let's go ahead and this is actually not going to be the user ID. We can see TypeScript is helping us out here. It's going to be the ID and password hash. So we'll just call this user instead of user ID. Log that user and expect user to be defined. Well, before it's going to be defined, we actually need a user in the database. So what I'm thinking, this is a good actually negative test case. So this would be returns null when there is no user by that email. So because this is spinning up a fresh database for each test, here we have not put anybody into the database, this should be null. So we can expect that to be null. Okay, and then let's see. So we actually have a function to insert a user right there. So let's go ahead and do that. Get that password back. And then insert user. It's going to take the database, email, and password. And this one does await. Okay, let's see what happens now if we run these tests. Okay, everything passed. And our first one, we got a log with our ID that was generated and our password hash. So that looks good. And then we also get null for returns null when there's no user by that email. So that was easy, worked out just as expected. So now that we have confidence in our query, we can jump back over here and we can put it to use. So here it's also time to wrap this in a try catch. And move these comments up. Those will go in here, and this will go in there. Now we can bring in our get user by email. And we're going to want to create a database connection the same way we did right here in our signup. And I can fold that down for a moment. Now we have that. We can provide it the database, and we can provide it the email that the user has given us. And then this will return our user as we just set it up to do. So const user. And if there is no user, so if we get null, because that's one of our options, then let's go ahead and return a 401 because they provided something invalid. So if no user is true, then return the context JSON errors with an array of invalid credentials. And then give that the status code of 401. There we go. Now, to verify the password, Bun has a built-in verify function, so this will be really easy. So we can set this as await bun dot password dot verify. You can see that option there. And verify, we can see takes the password and the hash. So that will look like the password that was provided to us here by the user. And then we grabbed the password hash from the database here. So we can put that user dot, and man, I love TypeScript's suggestions and autocomplete. It's so nice. And await is unhappy because I forgot to put async. There we go. Okay, and then this is going to return, we can see a Boolean if they're, verify a Boolean. So we can go ahead and set this to a variable. So our password match is going to be true or false. And here we can say if it doesn't match, then return a 401 again. So let's go ahead and do that. If no password match, return. Actually, we can copy this line of code because that will be exactly the same. Awesome. Now, if we do match, we want to generate a token. And lucky for us, we already have that logic up here in our signup function where we generated a token. So, and we're going to want to generate or assign a cookie as well. So let's grab both of these. Save for formatting. Now our user ID is inside of this value here, user ID. So we can delete that and say user.id. All right, we now have our token, and we put that token into a cookie. And we can send a success message. Here we can put a message and call it login successful. Nice and simple. And we can return the user ID and email. And then finally, if some error happens during this process, we can do a console.error, and then we'll be able to see that error in our server logs, and then return our context JSON with our error of internal, if I can spell, internal server error, and a status code of 500. So now that we have our logic written, let's go ahead and test this out to make sure that it's actually working as expected. So let's do a couple quick manual tests with our HTTP file. I'll go ahead and create a new request in here. And this is going to look actually very similar to this. So let's go ahead and copy paste this whole thing. And instead of sign up, it's going to be log in. All right. And this makes sense here. So basically, if we go over to the database, I had previously created a no@test.com. So we have this user in the database. So with no@test.com and a password of 123, which is what I had used before, this should successfully log in the user. So let's send this request and see what happens. Oh, I forgot to start up my local dev server. So let's do that. Bun run dev. Perfect. Get rid of that warning and try it again. All right, this is looking good. Let's see what we have here. So we have 200 OK. We've got auth token with our JWT. So that means, our token worked. And then we also have login successful, and we get the message with the ID and email that we expected. So perfect. Yeah, the happy path looks good. Everything is working there. Now, what if, for example, we don't send an email? Then we would expect this to receive a validation that, hey, email is required. There we go. Invalid email. And what if we're missing the password? Then we get both invalid email and missing password. Perfect. And let's see, what other test scenarios might we need? Yeah, password match. So let's say we have the correct email, but our password is not correct, 456 instead of 123, then we should not get signed in. And there we go, unauthorized, no token provided, and invalid credentials. Password does not match. Perfect. And I guess the last test scenario we can see here, if there is no user by that email, then we would also expect to get a 401. So if we check our database, we got test 123, 124, test. Let's throw in a new one. So hello@test.com. This does not exist in our database, and therefore we should get an unauthorized. Here we go. 401 unauthorized with invalid credentials. Perfect. So this is looking really good. All of the logic appears to be working as expected. And let's go ahead and write a couple automated tests just to make sure we're doing best practices. So inside of our index, here we have our sign up endpoint tests. We can do our login endpoint tests. So describe login endpoint. And the nice thing about automated tests is that you can run them all very quickly. And so if any of your logic changes as you're working through your app, you'll know if you broke any of your previous logic because of your automated tests. That's what they're so handy for. So let's say our happy path test is we should log in a user. So we can say it and should log in a user. Async. And if we take a look at our tests up above here, we created this helper function sign up request. Let's create another helper function for our login request. It'll make our lives easier. So we can do login rec equals, and this will also, let's save myself some typing, but call this one login request. Okay, so when you log in, we're going to log in with the email and password. We're going to default these, but we can override them as well. And instead of sign up, this is going to be log in. It's also going to be a post request, also going to be application JSON, and then pass the email password to the body. Okay, perfect. So that looks good. And then we can jump back over here and say for our happy path, let's copy this whole thing. When we log in a user, we want to use our login request. So we're hitting the right endpoint. And then that will log in a user for test at test.com. And the thing is, though, this user does not exist in the database yet because each test spins up its own fresh database. So we want to first create this user. So, or sign up, which is this logic right here. These two lines of code specifically. All right, let's add a comment. So this will be first sign up a user, and we might not need that. Actually, let's keep it. And then when we log in, we'll call this request to, and then response to, and JSON of response to. Response to should be of status code 200, And let's double check that. Yeah, this will return 200 by default. All right. So we've created our user, and then we want to log in. And this will not be user registered successfully. It will be login successful. Yep, right there. Login successful with the user ID of email as we set it up. So user ID and email of test.test.com, which is what we're expecting. And then we would also expect to get back our cookie with our token. So that looks good to me. Let's go ahead and run our tests. Close that server, bun test, and there we go. It's passing. I left a console log somewhere, maybe in the queries test. There we go. Get rid of that. And then we can write a sad path test. So one where, let's say, it should return a 400 if there's a missing email or password. Make sure our validation works. So then we can say, let's take these lines of code. So validation happens as the very first thing. So if we just say we're going to log in, but we don't provide anything, change that to request. This should then hit the Zod validation and give us back some errors. So we can change response to just response. And that status should be 400 for a bad request. And then our JSON should give us those error messages like invalid email and password must be 10 characters. So let's log out the JSON in this test so we can see it work. And then we can copy paste the exact error messages. Okay, there we go. So we're getting the error messages as expected, invalid email and password must be 10 characters. So great, let's copy that. And we can say we expect the JSON to equal this. Perfect. And we can run our tests again. There we go. And then let's write one more test around the password being incorrect. So it should return a 401 if incorrect password provided. So async. Now we're going to need to sign up a user again. So let's grab that code. Let's grab all of that. Okay, so we sign up and we're not worried about that response. So we can say that this is response 1. Request 2, we go to login, but we provide an invalid password. So test@test.com, same email, password 456, incorrect password. So then our response, we would expect that status code to be 401. Response.status to be 401. All right, and then we should get invalid credentials for the JSON. So let's do a console log to see exactly what that JSON is going to look like. And there we go, as expected, our invalid credentials. So we can copy this. And expect our JSON to equal. There we go. Let's run our tests one more time. And everything is passing. Awesome. So I'm feeling really good about this functionality. It's working as expected, and so we can move on to the next thing. So now we can add our log out functionality. So we can add in a new post request here to /API log out. Now, due to the stateless nature of our design, the way we log someone out is by deleting the cookie that they have in their browser. And lucky for us, Hono has a delete cookie function built in. So if we start typing delete cookie, and there we go, and delete cookie from Hono cookie, this is going to look similar to our set cookie in the sense that it's going to request that context, and then the name, we need to match the name of the token we had set, which is the Auth token. And then we can do set some config here. So this is going to look similar, where we want it available on any path. Secure should be true when in production. Same site should be lax and HTTP only of true. There we go. And then we can return a message, log out successful, something simple. And there we go. That is all we need to do the logout. Now let's test out that our logout functionality is working as expected. So testing the logout is actually a little bit tricky because we're not using a real browser. So if we were using a real browser, we would be able to verify that the cookie was removed. But in this case, we can't. So that's okay. We'll go ahead and test what we can. So let's create a test for this. And it should log out a user. And here we can go over to our test helpers and let's create a log out function. So log out, and this doesn't need anything. This will be log out. It's a post and no need for the body. So then we can call that logout request function. And we can send this request to our app, which will give us back a response. App.fetchLogout. And then we can get the JSON response from that. Now, we are expecting the response.status to be 200. Just that is the default when nothing else is specified, to be 200, a success. And then we're expecting our message logout successful. So let's go ahead and do a console log of the JSON, and let's log out the response as well so that we can see what this is looking like. Okay, so our response, we get the set cookie with an auth token of nothing. So that's a good sign. That's actually what we want, knowing that the cookie was deleted. So we can make an assertion for that, and we got our message logout successful. So let's copy that and put an expectation. So we expect the JSON to equal that logout, and then we can say our cookies from the response headers get the set cookie and expect that the cookies will have empty auth token. So let's do a regular expression match on that of auth token, capital T, token equals with the semicolon. So there should be nothing after it. Let's save that and run our tests again. And it passes. Perfect. Now we're ready to move on to the next. So now that we can sign up a user and log in a user, we want to create a route that is protected, that only a logged in user should be able to access. So before we do that, let's go ahead and add a CSRF middleware, and that will help to protect against CSRF attacks. And Hono has a nice middleware that will do this for us, so we don't have to do a whole lot. And we can just say we're going to apply this to all of our API endpoints by doing API/star. And then we can do CSRF. And we're going to want to import that. So that comes from Hono CSRF. There we go. And then there's another middleware that we want to bring in, and that is the JWT middleware. So we are receiving our JSON Web Token back from the user, and they want to access this protected route. We need to validate that JSON Web Token came from us and is safe to use. So let's go ahead and bring in this other middleware, JWT, from Hono JWT. And we can bring that down here and do another use. And we want to apply this only to routes that we want to be protected by authentication. So we'll say anything that is API/auth will receive this. and we can do JWT. And then inside of here, we need to provide it our secret. So we're getting some autocomplete there, and we're going to pull our process environment JWT secret. And then we're going to tell it to pull this from the cookie. And we have to let it know which cookie, which is the auth token cookie. And it's saying this, it could be string or undefined, but we know that our environment variable is defined, so we'll just tell TypeScript to ignore that one. And now this middleware is going to validate JWT tokens for anything in a /API/route. So with that set up, we can go ahead and create a protected route. So let's fold these. And let's do a simple get of the user's information. So we'll just call it API/auth/me. And this will be async with the context. And we will pull off the JWT payload. So we can say const payload with the, there it is, we got some autocomplete JWT payload. And then using that payload, we're going to get the user's ID. So then we can create a query to fetch the user by ID. So let's do a try catch, and we'll say fetch user by ID, and then send success with user data. Otherwise, send an error. Now we don't have a function to fetch users by ID yet, so we can quickly craft one up. And this will take the database and the ID, then we can say define our query, user query, and this will be select the ID and the email from users where ID equals the provided ID. And then we can say this is going to be user, and we're going to run this query. And return the user. Now, TypeScript sees the user as unknown, so we can go ahead and help TypeScript out because we know we are selecting the ID and the email in this query. So we can say this will be ID of string and an email, which is also a string. And if there is no user, then this will return null. So we'll enter that in. And then we can bring our query in here, get user by ID, provide it the database. So let's create a database connection here. And then we can get the user's ID off of the payload. And that will look like payload.sub. And then this we can set to user. That's what we will have returned. And if there is no user, so if we get null, then let's go ahead and return 404 not found. But if we do get a user, then we can return, this will return a 200, and we'll give the ID, which is the user dot ID, and the email of user dot email. There we go. That looks good. Now, if there's an error, we'll want to log that so that we can investigate it. And return a 500 to the user. There we go. All right, now we can test this out. So let's jump over to our index HTTP file. And this is a GET request. So 3000/API/auth/me. And now if we send this off, let's see if I have my local dev server running. There we go. We get 401 unauthorized, which is what we're expecting because we did not provide a JSON Web Token. We didn't send a cookie over. So we want to send a cookie, which we can do with this extension. But how are we going to get the cookie? So luckily this extension, this VS Code extension, has a way to save the cookie from a different request. So here we log in and we can set a variable. So we'll call it login. And then down here, we can access that login dot response dot headers dot set cookie. And then this will put the cookie from our logged in request in here, and we should be able to get a success. So let's send our login. Oh, that's right. I had put a fake password there for testing. I believe that was the real password. Here, we'll do no at test, 1, 2, 3. There we go. Successful login. We got our cookie, and now we can hover over this and we can see that we have our auth token saved in with this cookie. So if we send this request off, we should hopefully get our data back. And there it is. We get our user ID and we get our email. So when we sent it without the cookie, the JWT middleware rejected it just as expected. And when we send it with the correct cookie, we're able to access this protected route. So this is working as expected. That's going to be it for this tutorial. Authentication is a complex topic, so if you have any questions, let me know down in the comments and I'll try to get to all of them. And I will leave a link to the code in the description of the video. Happy coding and Godspeed.